Imagine looking at the horizon and experiencing a sunrise that covers half the sky. NASA has released images of an unheard-of phenomenon in which a star, dubbed Betelgeuse, lost its top, ejecting a significant amount of its surface mass. This event is called a mass ejection, and according to the space agency, the ejection was 400 billion times the mass of an ordinary solar flare. According to scientists, it evokes the experience of watching stellar evolution with a star in real time, slicing away such large portions of its surprising physical form, a catastrophic fireball from this red supergiant. Most of what we know is being challenged by this giant. Why did Betelgeuse blow its top off, and how will that affect the universe? Let's find out. Numerous stars make up constellations and are arranged in accordance with myths and legends that continue to exist. One of these stars currently used for navigation is Betelgeuse, which is among the largest and brightest stars in our night sky. The glittering star, brilliant ruby red, known as Betelgeuse, is located in the winter's upper right shoulder of Orion, the constellation of the Hunter. Astronomers recognize it as a monstrous creature aflame with 400-day-long regular pulsations in its heart. Due to its gloomy orange-red hue, Betelgeuse is easily identified. It's ideal for persuading opponents that stars do, in fact, have different colors. It is also referred to as Alpha Orionis, the second most brilliant star in the constellation, named in honor of the blue supergiant Rigel. Betelgeuse is an intriguing object for star studies and observations because of its varying characteristics and its odd name. Frequently, stars with the name Alpha are the brightest in their constellations, despite the fact that Rigel, the other bright star in Orion, is brighter. Alpha Orionis is Betelgeuse because of its name, brightness, size, and reddish hue. It is also one of the stars with the most fame. It's noteworthy that this star served as the character's model for Betelgeuse in the film Betelgeuse. It is the seventh brightest star that can be seen in most of Europe, North America, and Canada, and it ranks as the 10th brightest star in all of Earth's sky. It is fairly close to astronomers, but they are unable to pinpoint Betelgeuse's exact distance from Earth, although they believe it to be anywhere from 430 to 720 light-years away. Betelgeuse is the brightest red supergiant star and is the closest to Earth in our galaxy. There are just 200 red supergiant stars that have been identified. The Sun has a radius that is around 764 times larger than Betelgeuse's. If the star took the place of our Sun in the solar system, it would extend beyond the asteroid belt. This suggests that Earth, Mars, Venus, and Mercury would all be completely absorbed. Betelgeuse is 16,128 times larger than the Sun. This supergiant has 12,000,000 to 160,000 solar luminosities and is visible from 548 light-years away. This distant star has a surface temperature of about 3,600 Kelvin, making it only slightly cooler than the Sun. 13.3% of the radiance of Betelgeuse is visible light. If human eyes could see light at all wavelengths, Betelgeuse would surpass Sirius as the most brilliant star in the night sky. Betelgeuse loses about one solar mass every 10,000 years. The red star is surrounded by a nebula because this material is being thrown out unevenly in all directions from the star. A material cloud 150 times larger than Betelgeuse surrounds the star. The size of this nebula is also thought to be 30 times the size of an astronomical unit, or the solar distance between the Sun and Neptune, the solar system's farthest planet. Our solar system's sun regularly ejects mass into space, which is known as solar flares. However, the sun only ejects very small fragments of its outer atmosphere, known as the corona, providing the name coronal mass ejection (CME). As a result, coronal mass ejections and mass ejections from the surface can occur at separate times. When a star ejects a portion of its unstable outer atmosphere, the corona, a CME, is caused. Solar mass ejections, known as coronal mass ejections, occur very frequently and can have an impact on Earth and its inhabitants. CMS can travel more than 1,800 meters per second, ejecting magnetic fields and plasma into space, allowing them to occasionally arrive on Earth in a matter of hours. A CME can disrupt and harm Earth's satellites and power infrastructures if it takes place on the side of the Sun that faces the planet. Additionally, it occasionally puts astronauts in orbit in danger. The recent discovery sheds light on the extraordinary reason for Betelgeuse's activity stemming from 2019. The material that the star ejected exploded into space and cooled, forming a cloud of cosmic debris that concealed Betelgeuse's brightness from Earth-based observers. Additionally, Betelgeuse's renowned steady pulsing pattern has been altered. The CME on Betelgeuse is unusual because it released 400 billion times greater mass than a typical CME, causing the star to tremble like a dish of gelatin dessert, according to a NASA News release. According to Andrea Dupree, an astronomer at the Center for Astrophysics, the internal convection of the star's cells may be out of order, but the photosphere, which is what we perceive as the surface of the star, struggles to reconstruct itself. Astronomers have been observing the recurring pattern of the star's behavior, despite the fact that it is no longer consistent. All red giants, including Betelgeuse, are dying and surviving. To observe this process will allow researchers to learn a lot about the evolution of stars. Most stars evolve using nuclear energy to power the universe's fusion, which eventually burns out and causes a star to undergo a series of intriguing stellar changes before it finally passes away. When a star is born, it is composed of hydrogen, which the force of gravity fuses together in the star's core to create helium in a nuclear explosion. A lot of light, energy, and heat is typically released during the fusion process. This energy travels to the star's surface and is released as a photon into space. As the star ages, its primary fuel, hydrogen, runs out and helium begins to combine to form carbon. After the helium is used up, carbon and neon will eventually combine to form oxygen. When this happens, the fusion of neon with oxygen absorbs energy instead of releasing it. Because there is nothing to oppose the star's very powerful gravity, when the star's ions begin to fuse, it collapses in on itself, giving rise to an explosion caused by a supernova. Nature's most powerful forces can generate more energy than 10 billion suns. Stars alter their hue over time, from the youngest, hottest blue forms to the older, cooler red varieties, in accordance with the stage of stellar evolution they have reached. The Greek scientist Ptolemy, in 168 AD, strangely referred to Betelgeuse's color 3 centuries ago as having a ruddy hue. Earlier, Chinese astronomers had characterized the star as having a yellow appearance, which may suggest that Betelgeuse was formerly a yellow supergiant. Astronomers might improve their understanding of how red stars lose mass in their last days before exploding in a bright supernova from Betelgeuse's explosion. As Dupree notes, we've never observed a massive surface eruption of mass before. We are left with a star something that we are unaware of, completely understand. It's a totally new phenomenon that we can directly observe and deal with on the surface. Thanks to Hubble, we're watching stellar evolution in real time, but it's not clear if this development portends Betelgeuse's imminent supernova explosion. The results are so unusual that NASA issued a warning that Betelgeuse may not explode, even though it has not reached the end of its life but is nearing the end. Cosmic time is long and red supergiants perish quickly in comparison. Based on NASA's findings, Betelgeuse will explode in the next 100,000 years. Betelgeuse has been the focus of intense study since the 1st century BC. A scientist by the name of Sarah. More recently, a scientist Nance and her crew took care to determine the potential date and time of the supernova explosions of red supergiants like Betelgeuse, to find out how a star that large would behave over time. Nance and her team ran multiple simulations using Betelgeuse as a model, and they then compared their results to observations in the field. Why did Betelgeuse reduce abruptly and out of sync with its normal cycle when it is unlikely to explode for another 100,000 years? Betelgeuse was evicted from its home in the Orion-OB1 Association, which comprises the stars in Orion's belt, and has been seen moving through the interstellar medium at a speed of more than 4 light-years wide. By mid-February 2020, Betelgeuse had lost 2 to 3 times as much brightness, from magnitude 0.5 to magnitude 1.7, when it first started declining sharply in October 2019. By February 17, 2020, Betelgeuse's brightness had remained constant for nearly 10 days. The star had begun to brighten once more, however, Betelgeuse sounded like it had stopped dimming completely 5 days later, thankfully bringing an end to the dimming episode. Because there were no significant changes in the infrared on February 24, 2020, it appeared that the recent visual fading was unrelated to the anticipated core collapse. A different study found that, most likely, the star's dimming was caused by a circumstellar cloud of large grain dust. Absorption cannot occur from a significant influence in a study that uses submillimeter measurement wavelengths, but the fading appears to be caused by additional large star spots. The analysis revealed a significant rise in the brightness of Betelgeuse between May and August. Betelgeuse is so close to the Sun, which makes it nearly impossible to see prior to 2020. When Betelgeuse was aligned with the Sun, it was 0.4 magnitudes brighter, according to observations made using the stereosat light in 2020. In June and July, the star had faded by 0.5 magnitudes since its previous ground-based monitoring each April. Everyone was surprised by this because the maximum and subsequent minimum were expected to occur in August or September 2020 and around April 2021. In addition to Betelgeuse's fluctuations, it was common for the star to vary widely, making it hard to predict. The fadings seemed to indicate that a second dimming event might occur considerably earlier than expected. The finding of a second dust cloud emanating from Betelgeuse, linked in June 2020, suggested that a cool patch on its photosphere might be the cause of the dust. In August, the result of an independent investigation supported the initial hypothesis. The dust is thought to have been created by gas that the star had spilled. According to studies done using the Hubble Space Telescope in 2022, a cloud of dust may have been created by an ejection of mass from the surface. Material was ejected from the star's surface millions of kilometers away, where it cooled, compacted, and formed the star's fading dust. The broken photosphere, which was approximately multiple times as heavy as our moon, cooled as it vanished into space, creating a dust cloud that covered the star from the perspective of watchers on Earth. The fading, which began in late 2019 and continued for a few months, was clearly visible, even to backyard observers who noticed the star's brightness change. Even more remarkable, the 400-day pulsation rate of the supergiant has vanished since around 200 years ago. Astronomers have been tracking this cycle by analyzing changes in surface movements caused by Betelgeuse's brightness variations. Its disturbance reveals the blast scope. Astronomers have now developed a potential theory to account for the disruption. The star is also slowly but inevitably regaining strength, and the star's photosphere is regenerating. The normal cycle is disrupted, and the interior is ringing like a bell. A massive stellar surface mass ejection has been slammed, unlike anything else observed. There is still something happening that we don't fully understand. We can immediately observe this new phenomenon and use Hubble to discern surface features. Real-time observation of star formation, when will it occur? Probably not in our lifetimes, but in fact, no one really knows. It could be tomorrow or 1,000,000 years from now. Will the supernova annihilate Earth? Betelgeuse's explosion will not affect or end life on Earth because it will occur too far away. Astronomers estimate that for a supernova to be dangerous to humans, it would need to be within 50 light years. Betelgeuse is over 10 times farther away. Instead, everyone on Earth will be treated simultaneously to an extraordinarily breathtaking view of a very, very bright star in the night sky. Finally, because of Betelgeuse's significance, astronomers will be able to study the star when it undergoes a supernova. Betelgeuse is not now visible in the night sky, so don't go looking for it. Even if it went supernova right now, we wouldn't see much of it since it is in the midday sky during August. It's possible that Betelgeuse has already gone supernova. Betelgeuse is not only a significant Orion star, but it also plays a crucial role in the study of stellar evolution. Its size and distinctive features make it an exceptional laboratory for comprehending the phases of massive stars. The star in question is a red supergiant, a category that includes some of the largest and most luminous stars in the universe. Observations indicate that Betelgeuse might one day undergo a significant change, resulting in a stunning supernova event. This explosion is predicted to produce either a neutron star or, possibly, a black hole, depending on the remaining mass. Following the explosion, scientists are keen to gather more data about its behavior, especially regarding mass loss rates and surface modifications that can provide insight into similar stars across the cosmos. In addition to its scientific significance, Betelgeuse has also captured the public imagination. Cultural references, such as the classic 1988 film named after the star, have contributed to its position in popular culture. As it draws closer to the end of its life cycle, the interest surrounding Betelgeuse continues to expand, emphasizing its significance both artistically and scientifically.